This video is a presentation of the investigation conducted by the team in the last few weeks. Light contamination has been a problem that became more evident with the rise in aerospace development, and especially now that the private sector has become more involved in the aerospace industry. Larger constellations of small satellites are used to improve surveillance capabilities, increase orbits, and fill the gaps between high-precision data provided by big satellites. Missions are emerging whereby small satellites become fractioned, so that each satellite performs a functional part of a total system such as imaging, processing, and transmission. In recent years, the space industry has undergone a dramatic transformation. Instead of launching few, complex, large, and expensive spacecraft, the trend is now going towards the development of smaller, simpler, and less expensive satellites. Due to the miniaturization of once bulky satellites components, standardization, and substantially trimmed costs due to advances in design and manufacturing, the interest in small satellites has grown. Satellite constellations represent a great advantage for those areas that cannot be covered by just one device. This is where the need for a larger coverage system comes from. Nevertheless, since launching one single space exploration vehicle or satellite is a very complicated task, with the increasing number of satellites that are expecting to be in Earth's low orbit with the next years, it is hard to imagine the complexity of performing the task of launching and managing large amounts of satellites with the space highly crowded. Moreover, these megaconstellations also represent a threat for astronomy investigation. With the launching of Starlink satellites in 2019, astronomers from all around the world found their sky images ruined, along the fact that these constellations are very dazzling, distorting the data collected. Satellites represent a great innovation in the fields of research, exploration, and communication, and they still play a significant role for these areas. However, in the same manner that they help us, their excessive usage could also represent a threat to future exploration and research. The advantages in deploying small satellites for Earth observation include lowered business entry barriers and faster deployment due to the reduced cost and improved surveillance capability made possible by constellations. The proliferation of low Earth orbit satellites at altitudes less than 2,000 kilometers threatens our millennia-old ability to observe, discover, and analyze the cosmos from the surface of the Earth. It is a special irony that a technology result of centuries of study of orbits and electromagnetic radiation from space now holds the power to prevent us permanently from further exploration of the universe. Satellite constellations represent a great advantage for those areas that cannot be covered by just one device. Starlink is a project organized by SpaceX, which aims to provide high internet access throughout the planet by mega constellations. Currently, internet access depends on satellites transmitting internet via towers and cellular cables. However, these two options do not allow internet access in some remote areas. Today, only 57% of the world's population has access to internet. Disparities are felt in some regions, such as Central Africa, where only 12% of the population has access to the internet. Elon Musk's project would allow broadband internet access across the globe at an affordable cost thanks to several high-performance satellites placed in low Earth orbit, above 550 kilometers from Earth. OneWeb also joined the field of satellite communications with a constellation of 648 devices. Global services expect to begin this year. Additionally, the China Aerospace Science and Technology Corporation announced the launching of a mega constellation of 13,000 satellites. According to the filings, the project was divided into sub-constellations with altitudes varying from 500 to 1,145 kilometers. SpaceX became the largest operant of the world's largest active satellites constellation after launching 180 devices in 2020. The achievement was the beginning for Starlink, SpaceX's mission to bring internet access to every corner of the globe. In order to get that kind of connectivity, the company wanted to launch 42,000 satellites over the next decade. After launching the first satellites, concerned scientists complained to SpaceX and several measures were taken later to address the issue. One of the solutions offered by the company was a presentation of the data regarding the location of devices in order to help astronomers monitor them. Possible solutions. Given the current aggravation of a problem, a change in the design of telescopes is sought. This change increases the range, thus reducing visibility problems. LUVOIR. Consisting of a mirror 6 times larger than the recalled Hubble telescope, the change in design involves a change of diameter. It represents a 6-fold increase in resolution when compared to that of Hubble. This change allows the telescope to distinguish fainter, smaller, and farther away objects because it has 40 times the light gathering capacity of the older telescope. HAB-X. The change of design in HAB-X involves a new sunflower-shaped star shade, enabling the telescope to research faint exoplanets in unparalleled detail. While the size and configuration of the HAB-X telescope have not been yet finalized, the installation of a larger stellar screen with a diameter of approximately 236 feet will be pursued. LINEX X-ray Observatory. LINEX X-ray Observatory is a new project being developed by NASA and the Center of Astrophysics. It is planned to utilize a breaking technology to unveil phenomena with the use of cutting-edge technology. With an X-ray mirror perfect for gathering information from the rich energy released into the universe through cosmic activity. The design adjustments, in this case, includes a primary mirror of around 10 feet, making it larger than Hubble. Similarly, the aperture of the tube-shaped telescope varies and it is 5 times larger than Candra's, which is 4 feet in diameter. Origins Space Telescope. The Origins Space Telescope is around the same size as LUVOIR, with a diameter of around 50 feet. This proposed telescope uses a special cryocooler, a device to keep its instruments from overheating. The telescope's sensitivity is increased by keeping it cool, and it is up to 1,000 times more sensitive than any other infrared telescope ever developed.